Hi, everyone. I'm Aldo Hernandez, applications engineer with our transportation business unit at National Instruments. And today I'm going to talk about low-level automotive Ethernet testing that we call man-in-the-middle testing. Now, the reason why this type of testing is important is because as we move more behaviors and more features into software in ECUs, and we also consolidate all of that communication into buses like Automotive Ethernet, it's more common to run into issues where problems at a low level on the Automotive Ethernet, whether that is noisy environments or transceiver issues, get sent to the software, and then those are very hard to test. Why are they very hard to test? Going a little in detail into the Mac frame, the only thing that we normally see with off-the-shelf is what we have in blue here, which would be the payload. Everything else is abstracted out by the different layers of communication. So if I have an error that gets caused in any of those other parts, I won't be able to catch it or reproduce it. And now, to get around this issue, what I'm going to show you here is this man-in-the-middle this man-in-the-middle solution, where we are putting an FPGA, in this case a 6592R, that is connected with some Automotive Ethernet adapters into the dot and the simulator. Now, in the setup that I have here, the PXI that you see in the bottom is running my actual man-in-the-middle code. The one that I have in the top is doing the part of the simulator and the dot, where normally these two would just be connected together for a testing setup, or you could have two real dots. But here I'm going to have the PXI, and then the man-in-the-middle is going to be there. The things that we can do is I can just let it sit there and let traffic through without interfering with it. I can also log all of the traffic that is going through, and I also have the ability to break the connection. Now, going into the code itself, here is the basic code that I have. Quickly showing this is the connection, the control for the man-in-the-middle. I can see that I have control of my 4 ports that I can do. I can see some general information of the SFP adapters that I have, so like serial number and whether the link is connected and the speed of the link. I can also enable or disable stuff like speed negotiation or speed communication. Going into the man-in-the-middle information, I can see the number of bytes that I received in the man-in-the-middle input from the dot or from the simulator. And then how many frames I am sending to the other end of the dot. Now, as I have mentioned here, I have another card that is simulating the dot. In this is a slightly different code that basically is doing that whole simulation. Here on my port 0, I can send frames or receive frames, and then I can make sure that whatever I send here gets received by the man-in-the-middle. Now, let me make sure that it's all disabled. So here, for example, I can send some frames, and basically these frames are being sent on port 0 on this first PXI, and then they're going through the FPGA and then going back on port 2. And here on the ports 2 that you can see connected, I have everything that I received with the number of good frames that were sent. So I'm going to send this once more. And you can see the number of good frames that are increasing. Now, this is the standard behavior, where basically it's just there. It's not doing anything. Now, if I want to force any kinds of errors, right now here I have my man-in-the-middle settings, where I can enable them, and then I have different modes. This first mode that I have is the FCS, or frame check sequence mode, where I can break the CRC that is at the end of the Mac frame to force an error. Normally, these types of errors, if they happen, the ECU transceiver is supposed to throw them out. However, if there's any issue with that and then they get sent, they can cause an ECU lockup or any sort of errors on the firmware. So basically here what I'm going to do is this is going to break the FCS, and I'm going to start what would be good frames that come from the simulator. I'm going to break them. I have different options where I can break only a percentage or randomly break frames if I want to do some sort of stress testing of how many errors are okay and when does it start erroring. Now I'm going to run the generator once more. And here I can, now I should see the number of bad frames that get increased. So if I go back to what I'm seeing, I can see that in this case, the bad frames are the ones that are increased. Now, these are very good to catch. And as I mentioned, if I were to do this with an off-the-shelf connector, I would never even see these frames because the Mac should be throwing them out. One final note is because obviously Ethernet communication is bidirectional, I can also send this generator and I can see all of the traffic that is going from the communication. A follow-up part that would be very common is if I need to log any of the traffic or all of the traffic that I am seeing. This is also very useful. We log it in the FPGA and then we can retrieve that file, that log as a PCAP file. This is very useful once again because it's a lower level. It's not going to throw out any bad frames. So you get a much more complete picture of what the Ethernet communication looks like. Finally, once maybe I got past that first test or another test mode that is very common is as I get more information from the field, it is very common to start building a list of known issues or known frames that cause issues. Now, if I want to test, if maybe I did a fix and I want to test that I actually fixed the issue, this is a feature that we have where we have a binary file that you can load to the FPGA. Basically, you can replay that file and inject it on top of regular traffic. So basically, I can send regular traffic and also send my injected traffic at the same time. And I guess, well, here I was also breaking everything, so I maybe want to do that again. And that traffic gets added, and then with this, I can do any sort of easily do regression testing and easily check that the firmware is actually addressing whatever errors are found. This, if I want to test a different file, I basically just need to create a new binary file and upload it and send it through the man in the middle. Now, finally, here at the bottom, you can see we have the SFP port connection, where if I want to do even lower level control of my SFP port commands, I can both see the communication that is going, and I can, here we have, we already have examples for sending TCT sleep and wake if I want to, if I want to sleep or wake the board or measure how long it takes to sleep or wake. And finally, if I want to do lower level control, we also have a generic port read and write if they are needed. Thanks, everyone. That's all I have for today. If you would like to learn more, head over to ni.com where we have more information about this solution.